when working with circuits, you sometimes are interested in the amount of power which a circuit kind of drains, okay, or provides. So if it's a power source, or sometimes if it's a circuit itself, you want to be able to see, what the power is. Now, power in electricity, kind of in circuits, is defined as just voltage times current. Now, the question may arise, or you may ask, okay, so that's great. That's what the actual equation is, but why is that so? So if you think back of how power was originally defined, so if you kind of go back and when you were studying work and energy, and this is more on the mechanical side, not the electricity side, you may recall that power was defined by simply the amount, okay, or the change of energy divided by time. Or in other words, you can think of how much work you have done or how much work something does in the amount of time. So really it's all about the speed, okay, or the rate of doing work or transferring energy. That's what power is. And I can put up a link to the original definition if you like. Now, if you want to know, okay, so how is this related back into, okay, this particular equation in electricity and magnetism? So how does it translate back to voltage and current? So that answer can be easily done because of the fact that you do know, hopefully, how voltage and current is defined. So if you think back of voltage, so voltage, okay, was just defined by the amount of, okay, the potential. So this is the electric potential that you have per the amount of coulomb, okay, so that you carry. So if you think that way, now let's kind of go back into the units in that case, and this would be the units of metric standard units in this case. So if it is the amount of potential energy that you have, electric potential energy, so well, that would be measured in joules. And this, okay, is per every single coulomb that you have of charge. So that is the unit of voltage. Now, we would call those just volts in general, but I want to be able to use joules and coulombs because I want to show you how the power is just voltage times current. Now, if you go back and think about current, so current, and again, this is now, so how many coulombs are passing by the amount of time, so some unit of time. So, how many, basically, if you think back, electrons, now we typically relate back those, the electron flows back into coulomb flow. So what we have is the amount of coulombs that pass by, and this is per unit of time. And now the unit of time, if you think back of metric standard, of course, is the second. So now it's very easy to be able to see that, okay, well, if power, okay, is defined by voltage times current, then you can see that if you take these two particular units, or any units that are consistent, then what you're going to run into, well, volt is going to be joules per coulomb, and then current is the amount of coulombs, okay, per second. So notice that the charges, okay, will be gone. And again, as long as you're consistent in all your units, this is going to happen, and what you're going to find, you're going to get that this is just joules per second. And of course, joules per second is a watt, right? So if you think back, so right here, so this is work, so the amount of work that you do or the amount of energy that you transfer, well, this is in joules, and of course energy is in joules, and this would be in seconds, okay, and this is in seconds. So this is just joules per second, which is defined as a watt. And that is why power is voltage times current. All right, thanks for watching. Happy studying. Bye, everyone.